Assalamualaikum and good morning everyone. I'm Fatin Shafika binti Muhammad Shafarin and my metric number is 16DKA23F1049. So today, my friends and me will be discussing about Highland Tower collapse, one of the most tragic building failures in Malaysian history. The incident happened on 11 December 1993 in Taman Hillview, Ulu Kelang, where Block 1 of the three-building Highland Towers complex collapsed, tragically taking 48 lives. This collapse was triggered by several days of continuous heavy rainfall, which caused a landslide that destabilized the foundation. As a result, this incident became a turning point in Malaysia's approach to hillside construction. It highlighted the need for better geotechnical assessments, adequate drainage systems, and stricter building regulations to ensure the safety of structures built on steep slopes. Through these presentations, we will explore the key factors that lead to this tragedy and the lessons learned for future hillside developments. Now, we will continue with location review. So, the Highland Towers complex was located in Taman Hillview, a residential area in Ulu Kelang, Selangor. This region is known for its picturesque but steep terrain with lush, dense vegetation that makes it both visually appealing and geotechnically challenging. Built in the early 1980s, Highland Towers consists of three 12-story apartment buildings constructed on a hillside. Although the elevated location offered scenic views, it was inherently risky due to the steep slope, unstable soil conditions, and the area's tropical climate, which includes heavy seasonal rainfall. Leading up to the collapse, days of continuous rain had saturated the hillside soil. Combined with insufficient drainage systems, this created ideal conditions for a landslide. This case reveals the critical importance of location assessment and understanding the natural risks associated with hillside developments. For the next slide, I will pass it to my friends.
My name is Muhammad Patricia binti Muhammad Fazli, 60 DKA 23F1042. Triggering mechanism and reason for the collapse. Geotechnical issue. Poor soil stability. The area was a hilly terrain with unstable soil prone to landslides. High water pressure. Continuous rainfall encourages poor water pressure in the soil, reducing its stability. Next, foundation problems. The buildings were constructed on unsuitable soil without adequate foundation support for a hillside development. Drainage and seepage issue. Insufficient drainage system around the building allowed rainwater to accumulate, further destabilize the slope. Seepage led to water infiltration, which weakened the soils, stretch and contribute to the landslides. Construction and regulatory oversight. Lack of strict regulation for hillside construction during that time. Connection oversight in geotechnical assessment before the construction for the tower. In situ measurement and monitoring system. Slope monitoring instrument. Inclinometer track horizon soil movement on slopes, providing early warnings of slope deformation. Piezometer measurement for water pressure within the soil, helping to assess soil saturation level during heavy rainfall. Trilometer detect changes in slope angle, indicating foundation slope fill. Soil and groundwater monitoring. Soil moisture sensor Monitor soil moisture level, helping detect excessive saturation that reduce soil strength. Groundwater observation well track fluctuation in groundwater level which impact soil stability. Surface displacement measure any movement on the slope. Surface signaling increase landslide risk.
Assalamualaikum, my name is Nur Najla Nasuha binti Yuzi. My number matric is 16 DKA 23F 1046. I want to tell about proposed prevent and solution. A. We have preventive measurement. First, throughout site assessment, test soil and water flow to identify risks and plan for construction. Second, we have a proactive drainage system. Install drain around foundation and slope to manage water and check them regularly to prevent blockage. Slope tracing, create step of slope to spread weight and reduce landslide risk with drainage channel on each side. Third, we have retaining wall and soil support. Build walls to hold soil in place with drain to release water pressure. Add extra support if needed to stabilize the hillside. B. We have a solution and remedial action post-construction. First, we have reinforcing with pie foundation. Install deep pies to transfer building weight to stable soil and bedrock by passing unstable surface layer. Second, we have surface drainage system installing using surface drain to direct groundwater, keeping soil dry and improving stability. Third, we have slope monitoring and early warning system. Install inclinometer and piezometer into monitoring slope condition. Lastly, we have a soil treatment technique, grounding and chemically stabilization. Inject cement on chemical into soil to increase strength and reduce water infiltration.
Now, I will discuss about the slope redesigning graph. We use Felonius slice method to do this graph. As a result, the radius is 64 meter and the angle is 113 degree. Next, we will go through the calculation. First, we need to find disturbing moment which weight shear area or W need to multiply by distance of W to the point, and we will get 343,554.05. Then, we need to find shearing resistance moment, and we will get 371,598.18. Lastly, we need to find factor of safety, where disturbing moment divided by shearing resistance moment, and we got 1.08, where E is more than 1, which is in the safe condition. Now, I will pass it to my friend to discuss the next slides.
For a conclusion, the Highland Tower disaster highlights the critical importance of proper planning through site assessment and effective drainage system in hillside construction. This collapse of Block 1 in 1963 caused by heavy rainfall and poor drainage and slope stability. This resulted in the tragedy of loss of 48 lives and intensive the risk of building on unstable terrain without adequate safety measures. This tragedy led to improvement of building code and construction practice in Malaysia. With a focus on safer hillside development, key lessons include the need for reinforcement drainage, slope stability, and regularly monitoring to prevent future disaster. By applying this lesson, future hillside projects can make safer, protecting both life and properties. And the picture of tragedy. First, retainer wall collapse. Second, landslide occurred caused by the collapse of retaining walls. Block 1 started to collapse. Fourth, Block 1 partially collapsed. And 5, Block 1 entirely collapsed. So in here we have two references that we refer to do this case study.